since our focus at UP42 is more towards the very high resolution imagery, at the end, maybe I wanna focus a bit more on what where the very high resolution imagery fits into this general schema. So let's start. Agenda is we're gonna briefly talk about forest management, what it is, and wildfires, and what are the remote sensing technologies to support these management, and some of the use cases, and later that we'll see some briefly what UP42 enables in those things. And every presentation should start with a map, of course. This is my favorite maps, Global Forest Watch. You can just see all the forest change all around the globe. Not very in high resolution, but it's still nice. And the thing that when we talk about fires, we will mostly talk about actually the change, and the change is not only with fires. There's a huge change is going on in the forests. Some are intentional, some are not, with the wildfires and etc. And you can just track in the Global Forest Watch. And the thing is that when we are also talking with management, lately, I think there is this paradigm of saying that if you can't measure, you can't manage. It is a controversial thing, to be honest, saying that in management. But what we are talking about actually with these technologies is that in the end, we come up with something like a model. We are modeling what we are looking at, what we are looking, and then in this case, there are what they mention around is either forest inventory models or forest resource models. FSN is one of them, from the European Forest Information uh, um, Institute, I think. And there, for example, we start with the very very minimal unit of the thing that we want to manage. In this case, trees, and then you basically measure different parts of the trees, and through these measurements, you basically track these models and what's going on in them. And if you attach them into a location, actually, what we are talking about now is like geospatial forest management. This is another institution initiative by Group on Earth Observation, which is a very nice organization I can recommend. You can check. I think it's a collaborative project where they basically share their in situ data on their measurement. And if you actually also put all these measurement in time, you end up something like spatial temporal forest management, and also maybe add more layers like weather data and other analysis, something like you can see in NASA fire information resource management system. They are actually trying to guess the active fires in different parts of the earth, looking at a little bit low resolution data with mostly MODIS and Landsat, and you can check. I recommend. Um, it doesn't mean exactly that these are always active, but it's a bit of alarm state. And at the end, actually, in the what we are doing around this forest management is at the end, we want to actually use these, systems and models in our daily lives. Watch DT was one of them. In the California wildfires, people told me that actually most of the people there was using this. And when we can do all these management into something like maybe this, it's actually very useful in our real lives, and then we can calculate many things in those models, what is changed and what is not. um, I checked what is the causes of fires then. Vegetation fires, basically, because it mostly start from the vegetation and then goes through the forests. And there is a model, like classification model from FAO, and there they classified the things that what can cause actually forest fire. They're actually with technology that we're gonna talk today. I think is around the causes, maybe because of electrical power, railroads, or through vegetation management, agriculture burnings, waste management, and recreation. Around these topics, actually, we can end up something that we can maybe monitor. And if you check the some statistic, you'll see actually the most of the fires start because of human activity, and then through that, actually, it may grow. And if we are talking about wildfire, actually, we need to a bit do this distinction between the fire and wildfire, because that actually, if you look at the time in the first fire happens and started, before, during, and after, basically, if you can prevent it in the very early stage, it doesn't grow into a wildfire. So what people are doing is that really focusing on this early prevention. And to do that, actually, you have bunch of analysis beforehand, like as I mentioned, this forest inventory monitoring, human activity monitoring, vegetation monitoring. Vegetation in this sense also deemed as a bit fuel, because they basically serve the initiation of the fire. So you basically monitor that. Also the utility around the, maybe the utility lines can cause, and how you manage those actually is very important. And things like impacting the health of the vegetation in the forest, like pests, also being monitored. And if you really cannot prevent it in early stage, uh, it is actually getting into a wildfire, and it becomes really, really hard afterwards. And most of the time, the only solution is just really fly away in those situations. And the most recommended ones, and in that case, you want to actually check, monitor the wildfire spread. And also you want to actually do a nice public communication, which is not being talked around, but it is very important element of managing a wildfire event, because it's actually all the time, like since my childhood, I know that all the phones are blocked in the institution that my father was working, and there are many false claims around. There is a huge panic state, and it's already a very tragic event. And doing the public communication in those events is also very important. And afterwards, what you do is basically you want to check the burnt area, what is changed, and you want to apply some restorations, and if you need to do some insurance and legal claims. The people basically is trying to get those data, trying to get the data in the ear- mm, before of the event very nicely. Mostly, you see people are actually using airborne technologies, like lidar technologies, very active laser scanning, or passively getting it- i- i- infrared thermal uh, scanning, or they also may use aerial imagery. And if you check actually in those technologies, you see different wavelengths, looking at the and in different wavelengths you understand different part of the things, like active fire, burnt area, maybe fuel moisture, and you can trace some gases maybe. And depending on the technology and the spectral technology it has, you can understand different things. But if you go to a bit more like the space-borne technologies, you basically end up. It's very common that the optical RGB images, but you also have in different spectral, uh, in different wavelengths, like short wavelength infrared. You can actually easily maybe penetrate through the smokes. Like in these Maxar imagery, you see the differences between the RGB and the silver bands. You can actually monitor maybe the wildfire spread. And there are also like different technologies, like uh, digital service models. You can understand the tree height a bit easily if you also check the digital terrain model lighting in those cases. So what I mean is that there is not only in this space you have optical, but you have actually different options to get the different part of these measurements that we talked about in forest inventory and resource models. And there, I think in the second talk, we will explore more the hyperspectral. You also have synthetic radar aperture imagery and even thermal imagery nowadays on the space. And it gives many of the details of the situation of these models before, during, and after. The main trade-off in the game actually here is that you have a spatial resolution in all of your measurement. Either it is from the actual location, which is the best option, for which is the best resolution, or you may end up is a bit lower resolution of data to track anything. If we can check these three different images, this 50 centimeter resolution, 1.5 meter, and then 10 meters, you can clearly see the resolution differences. And the main, actually, the game, I would say, or like main play in those situations is that, I mean, if you go to the location, exact location, it is the best. But you cannot always do the same calculation again and again in time. uh, Even if you fly some aerial device, you might still have a bit large gaps, like maybe 5 years and 10 years people are updating their data. But uh, in within this time range, you can first end up in a not updated data, might lead to actually a wrong risk calculation, or actually it is sometimes expensive just to do these, just to fly an aerial device. uh, I added like this too, but I'm not sure if you can share this. In one of the studies, they checked actually the cost effectiveness of remote sensing technologies and comparing them. And through that, actually, you also understand the idea of the looking at these different technologies in the cost sense. And there is also another report that I found in one of the files. Actually, inaccurate data on the forest fuel may actually lead to some of the um, analysis in a wrong way, that so actually they couldn't foresee the thing is coming. um, and that's why, like, very high resolution imagery in satellite also, it's not always possible to get them, but nowadays it's you can get daily in some of the providers. And with these imagery, you can see in the before at canopy density, canopy height, and health, some login activity. You can track the vegetation quite well nowadays, and maybe vegetation around the power lines and the pest damage. You'll see people are actually doing it. There is a nice research around. You can easily find, I think, different studies around that. And also, uh, early fire detection is usually is acquired by geostationary satellites, actually. But these are usually high access satellites that it's not very easy to access them. But there are geostationary satellites that can even track the fire in the early stages nowadays. And during the wildfire, you can track the wildfire spread, and you can see maybe if it goes to very risky settlements, and you can track that. And actually, it is mostly used in the public communication nowadays. You see many news about, using either different providers imagery. It just gives some kind of factual information about what is going on in those chaotic crisis states. And then afterwards, you can get the burned area of the what is burned. Again, the canopy density, height, and health of the restored area. And then it is actually also very useful for insurance and legal claims. In those different technologies and games, what UP42 does is actually helping you for technical and commercial challenges you may have if you want to just try very high resolution imagery. Because sometimes you just need to act quickly, and you need to be prepared for that. And sometimes maybe the very high resolution imagery fits quite well into your situation, but you just cannot really get those high resolution imagery like overnight. There are some kind of um, commercial and technical constraints you may have, and it is not very easy to figure out very fast. And in that case also you end up, I talked with people and they mentioned actually they are struggling a lot with dealing with satellite imagery itself. And for all these kind of concerns, what we are trying to do is that making it very easy on the catalog, uh, on the catalog of different providers. You check where is the imagery and from what time. And if you also want to task beforehand, because some people actually can understand, maybe before 2 days they can see that this fire might come very likely, you can just task a satellite. And in all these process, we try to make it a bit easier for you managing the data, processing the data, and also all these compliance and account related, payment related things, make it for very easy for you. And what I actually like the most, the documentation, and the customer success team is doing a very good job supporting all of the concerns around this. And they're actually, yeah, there you can use many things very easily. And even if you don't actually use up42, just using and checking up42 will teach you many things about what the EO market, the current status of EO market, and what are the things that actually you need to manage by yourself. I tried to add all the resources that I checked through. These some research and organizations I like, uh, some of the use cases and applications, and then also some newspapers about this topic, that where you can actually have much more information.